Topic 3, cell size. How a cell metabolizes and functions and its efficiency will depend on its size. Cellular waste leaves, and of course, thermal energy dissipates out of the cell membrane. And inside of the cell membrane, they take on nutrients and other resources. So, chemical materials must enter through the cell membrane. And it's at a certain size, it begins to be too difficult for a cell to regulate what comes in and what goes out of the plasma membrane. Cells need a very high surface area to volume ratio in order to optimize and be efficient in the exchange of materials that go through its cell membrane. Formulas to calculate the surface area to volume ratio for cells will be given to you on a formula sheet, but it is a little different for cuboidal cells as spherical cells. So for cuboidal cells, we're looking at the total surface area is the height times the width times the number of sides times the number of boxes given to you. And this is best explained with an example. Now volume, that is height times width times length times the number of boxes, which is going to end up being cubed. And then in order to get the ratio, surface area to volume ratio, it's expressed as a fraction and then as a whole number. Now when calculating it for spherical cells, surface area is 4 pi r squared. And then in order to calculate the volume, you're going to use 4/3 pi r cubed, and then a surface area to volume ratio. So practice by putting these numbers into your calculator. So my first cuboidal cell has a length of 3. Now it's a cube, right? So the length and the width are the same. So surface area is 3 times 3. The cube has 6 sides, which is where the 6 comes in. And then we're talking about 1 cube, so that's 1. So we have 3, and then this is 3, and then there's 6 sides, and then 1 overall cube. When I multiply those numbers together, I get 54. So it's 54 units squared, technically. Now in order to calculate volume, that is length times width times height. So 3 times 3 times 3 times the number of cubes, which is 1, gives me 27 cubed. In order to get surface area to volume ratio, I'm going to put surface area, which is 54, divided by 27, which is its volume. Divide those two numbers and I get 2. Example number 2 is going to show you a cuboidal cell, but it's multiple units. So in here, it's just given to you that the side is 1. So to find the surface area of this cell, it's 1 times 1. And then, of course, this cube right here has 6 sides, and there's 27 of them. If you were to count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 3 is 27. So when you multiply those numbers together, you get 162. Volume is identical to how we calculated on the first cube. So you're just calculating it for the 1. So length times width times height, 1 times 1 times 1, and 27 cubes, units. So that's 27. 1 times 1 times 1 times 27. You divide those two numbers, you put them as a ratio, 162 to 27, and that gives you 6. So when you're looking at these two, which would have the best exchange of material through the plasma membrane, and what we want is option number 2, because it has a higher surface area to volume ratio. So we're looking for the larger number when we are comparing cells. Surface area to volume ratio for a spherical cell is calculated a little differently. We're going to do the surface area to volume ratio. So just the formula for surface area of a sphere is 4 pi r cubed. And we're going to divide that by volume, which is 4/3 pi r cubed. which the surface area to volume ratio will simplify to 3 over r. Oh, listen to that thunder. What this basically tells us that as the radius increases, the surface area to volume will decrease. So the larger the radius, the lower surface area volume ratio. So I've given you 2 examples. Let's try it. Want to make sure that you're able to put this in your calculator correctly, so I've given you the answers. Here we have a spherical cell number 1, which is r equals 5, and spherical cell number 2. Now, just by looking at that, which do you think has a higher surface area to volume ratio? Which cell is more efficient? So cell number 1, the ratio is going to be higher. You can see when I've calculated it out right here that it is higher. So 0.6 is greater than 0.37. But here I've worked it out for you so that you can see how I got those numbers. And it's okay to do it line by line and then divide the 2 numbers and write it all the way out. That would be appropriate. You don't have to set it all up and shortcut it. But each of these individual formulas are going to be given to you. So take a moment to write these down, put them in your calculator, model after the numbers you can see here to make sure you get the correct numbers, and then try a couple of practice problems. Try practice problems 1 through 9, and then 10 and 11 ask you questions about 1 through 9. I've loaded the answers in random order for you,